One major thing to take note of in R is to know how to represent or arrange your data in Excel before importing it to R. So if you want to conduct one sample t-test, all you need to do is to create a group, and we know this group is from a particular population. That is why all the numbers is just represented as 1. Then you impute the values of the dependent variable, which is length, by the side. In the case of unpaired t-test, where you are comparing between two different populations, you give the samples of population 1, the first population, a number different from the second population, and then you impute a column. You record a column for the dependent variable. In the case of paired sample t-test, you don't really need to create a column for a group. All you just need to do is to create column for the values before and after, which is the length before represented as A, length A, and the length after was represented as length B. Here in R, I will import the different set of data that I showed us in the Excel sheet. So for the data for paired sample t-test, this is the code that I used to import it. And remember, I said whenever you want to import any code, you can assign the code a particular name. And in this case, I assigned this code that I used to import the data for the paired sample t-test. I assigned the table a name called paired, so that I will make reference to it in other codes or other arithmetic in other commands that I want to do. So if you want to see the result of what I imported, you can just click on this paired and then run. So you can see this is the result of what I imported. This is exactly what I wrote, what I typed in my Excel. And if I click on paired, I've already run all this previously before coming to this section. So if I click on unpaired and I click on run, it will show me the exact data that I have in Excel. Likewise, if I do the same for one sample and I run, it will show me the exact thing that I have that I had or imputed in Excel. Previously we said before a data can be run using t-test, it needs to meet some assumptions for parametric test. So part of those assumptions is that the variance must be equal and it must be normally distributed. So we are going to use Levene's test to check if the variance of the data is equal, and we're also going to use Shapiro-Wilk's test to check if the data is normally distributed. So to start that, we need to make the group de facto, as in the case of unpaired t-test, where we have group and then dependent variable in the table. So this is the code for making group de facto, and here we have table name, $ factor name, then other code goes like that. So you change this table name to the name of the table you imported, and in this case the name of the table we imported is unpaired. Then the factor name is group. Then you do the same for this other side, unpaired and group. When you're done with that, you click on run. So with this, we've made group de facto. So you can then proceed with Levene's test. But before you do that, you need to load two packages, the car and the HMS package, to run the Levene's test. So you just come here, you type car, so it will bring the option of car here. Then you click on this section to load car package. Then you still come here, you type HMS, and then you click on HMS. With this, you've loaded the two packages and you are good to go to conduct Levene's test. So this is the code for Levene's test, and this section is name of dependent variable. So the name of our dependent variable is length from the graph plotted, and the factor name is group. Then the table name is unpaired. If you run this now, you get your result. So remember, when p-value, this is the p-value here, PR, when p-value is less than 0.05, it means variance is not equal. But when p-value is greater than 0.05, it means variance is equal. So in this case, p-value is greater than 0.05, which means the variance of the two population or of the two samples is equal. For the Shapiro-Wilk test, we don't need to load any package. So this is the code for Shapiro-Wilk test. So we just need to input the table name. The table name that we've been working with is unpaired. So we'll type unpaired here. Unpaired. Then the name of the dependent variable that we are working with is length. We'll type length. Then if you check that table, if you check the previous table, we have 5 groups of 5 groups in group 1, 5 replicates in group 1 and 5 replicates in group 2, making 10 altogether. So I would indicate the range of the values. The range of the value will be from 1 to 10, since we have 10 samples altogether. So once I do that, I would not forget to also assign this code to a particular name, E, because I will still refer to it in this other code down here. So I refer to this unpaired $, length, and this range to a particular name called E. So after doing that, I'll say run. After running, then I'll say run for this Shapiro test. But make sure that the name you assign to this code is the same name you are writing here, or the same name you typed in the parentheses here. So once I'm good to go, or once I'm sure of that, I'll click on run. So this is the result of the Shapiro-Wilk test. So for the Shapiro-Wilk test as well, if the p-value is less than 0.05, it means data is not normally distributed. But if the p-value is greater than 0.05, it means the data is normally distributed. So here our p-value is greater than 0.05, meaning our data is normally distributed. So since we are sure that our data is normally distributed and the variance is equal, then it is fit for parametric test. And then we'll proceed with two sample t-test, which is unpaired, for the data that we just used. So we use this code to do the t-test. We use this code for the unpaired t-test. So now we raise this name of dependent variable. Remember, our name of the dependent variable is length. Then the factor name is group, and the data data is for the table name. The table name is unpaired. So once you're done with that, you say run. If you say run, you get the means of the two different groups, the mean of group 1 and mean of group 2 here. And then when you scroll up, you see the p-values. You see the p-value for this test, and the p-value is equal to 0.1466. So this is the code for one sample t-test. And if you can remember, we said the name for the data for one sample t-test is one sample. Then the name of the dependent variable is length. Then remember, for one sample t-test, you are comparing the mean of a particular sample with an hypothesized mean. So the hypothesized mean, you insert the value here, value of the hypothesized mean. Let's say I want to give the mean, my hypothesized mean 15. I will impute it here. Then I'm asked, is it paired? I say false. Is the variance equal? I said true. Then is the confidence, what is the confidence level? 0.95, which is still equivalent to, confidence level is 0.95. So once I'm done with this, I'll say run. So here I have the mean of the one sample, and then this is the p-value, 0.4803. This is the code for running paired sample t-test. So the table name that we imported previously is paired, and the name of the first dependent variable is length A. Remember, the L for length is capital letter. If you make a mistake to type in small letter L, you get a wrong result. So I click on length A, then I change this accordingly. The table name is still paired. Then the name of the second dependent is length B. After that, I'll check other parts of the code. They said alternative, is it two-sided or two sample? Yes, it is two sample. Then MU, do we have hypothesized mean? No. That is why the score here is 0. Then is it paired? It's true. The T means true. Then is the variance equal? Variance equal true. Variance equal to T. You can as well type just normal T. Instead of true, you can write normal T. Then the confidence level is 0.95. Once you're sure about all what you imputed, you then run. So after running, you get the p-value, and the p-value is 0.1789. Remember to always impute the right words or the right letters to get accurate results. And for sure, at the end of this video, I'll add all this code to my comment section